White box and black box testing in software engineering. White box testing and black box testing are two complementary testing techniques used in software engineering to validate and verify the functionality, correctness, and quality of a software system. Let's explore each of these testing approaches. 1. White box testing. White box testing, also known as clear box testing or structural testing, focuses on testing the internal structure, logic, and implementation details of the software system. Testers have access to the source code, architecture, and design of the software, allowing them to examine the internal components and their interactions. The objectives of white box testing include: 1. Ensuring that all paths and branches of the code are tested. 2. Verifying the correctness of individual functions, modules, or components. 3. Assessing the performance and efficiency of the software. 4. Identifying code defects, such as logic errors, boundary conditions, or incorrect data flows. 5. Evaluating code coverage to ensure that a sufficient portion of the code has been tested. White box testing techniques include: 1. Statement coverage. Ensuring that each statement in the code is executed at least once during testing. 2. Branch coverage. Testing all possible branches or decision points in the code. 3. Path coverage. Examining all possible paths through the code, including loops and conditional statements. 4. Code reviews. Manual inspection of the source code by developers or testers to identify potential issues or improvements. 5. Unit testing. Testing individual units or components of the software in isolation. 2. Black box testing. Black box testing focuses on testing the external behavior and functionality of the software without knowledge of its internal structure or implementation details. Testers approach the system as a black box, with inputs and expected outputs, and evaluate whether the system behaves correctly according to specified requirements. The objectives of black box testing include: 1. Validating the software against functional requirements and specifications. 2. Assessing the system's behavior and responses to different inputs. 3. Testing system functionality without requiring knowledge of the internal code. 4. Identifying defects or discrepancies between expected and actual outputs. 5. Assessing the system's usability, user interface, and error handling. Black box testing techniques include: 1. Equivalence partitioning, dividing the input space into classes or partitions and selecting representative test cases from each partition. 2. Boundary value analysis, testing the system with inputs at the boundaries or edges of equivalence partitions to identify potential errors. 3. Decision table testing, creating decision tables to represent different combinations of inputs and outputs and testing all possible combinations. 4. Use case testing, testing the system using realistic scenarios or use cases that represent user interactions with the software. 5. User acceptance testing, UAT, testing the software from an end-user perspective to ensure it meets the requirements and is suitable for its intended purpose.